All right, let's talk about taking the square root. So we talked about this in the past and we identified perfect squares, and we can simplify the square roots if it's comprised of perfect squares. So why don't we do some review? But now we're going to add in the possibility of having the positive and the negative solution. So the square root of 49 is a perfect square. It's going to be 7. And because I can multiply positive 7 times 7 gives me 49, but I can also do negative 7 times negative 7. It'll be 49. So we can add in the plus and the minus 7 for both of these. All right, the square root of 45 is 5, but again, you can do the plus and the minus of 5. Now, the square root of 12 is not a perfect square, but we can simplify it by using the square factors. So the factors of 12 include 12 and 1, 6 and 2, and 4 and 3. And the one that has a perfect square is going to be 4 and 3. So if I take these and rewrite the inside as the square root of 4 times 3, then split them up as the square root of 4 times the square root of 3. Once I take this square root of 4, then my answer is going to be plus or minus 2 times the square root of 3. So this is going to take the positive solution of 2 times root of 3 and the negative solution of minus 2 root of 3. All right, same thing if I'm doing a fraction. Because I was able to split these when I'm multiplying inside, I can do the same thing when I'm dividing. So if I just take the square root of 16 divided by the square root of 9, I can simplify both of those. So the square root of 16 is 4, the square root of 9 is 3, and because it's just a fraction, then I can do plus and minus that applies to both of these. So how are these related to quadratic equations? Well, we can solve quadratic equations that don't have a bx term if we can solve for the x value. And we know that there has to be two solutions, so two solutions will come from the positive and the negative once we take the square root. So just solving straight up for x, we can add 8 on both sides on this first one, and that gives us 2x squared is equal to 8. And then I can divide both sides by 2 to get x squared is equal to 4. Once I take the square root of both sides, then x is going to be equal to the positive and the negative solution of the square root of 4. So that's taking into account plus and minus 2. All right. These x-intercepts for this problem will intercept at positive 2 and negative 2 along the x-axis. So this would be my answer. Now, if I do this next one, I can also have a number on the right-hand side, but same rules still apply. Apply inverse operations and solve for this. We have 1/3 x squared is equal to 27. And then I'll multiply both sides by 3. 3's cancel. And I have x squared is equal to 27 times 3 is 81. And if I take the square root of that, then x is equal to the positive and the negative of the square root of 81, which is 9. So completing the square visually. So in the last problem, we were able to find the solutions if we could take the square root. However, in this case, right, it's kind of hard to combine these x's because they're not like terms. But if we can somehow rearrange the terms into a square, then we can take the square root. All right, so here are some shapes that we're going to work with. We have x squared, bx, and c. If we take the dimensions of these areas along the side, we have x and x. This is the same as this dimension, so we have x here. However, the other dimension along the top has to be b. and the dimensions for C are not important. All right, so if we can rearrange this into a square, we can take the square root. All right, so what I'm going to do is take this bx term, and along the b side, I'm going to split it in half. It's cutting the b in two. And then I'll have my square right there. And by doing this, I can rearrange half of the bx, half of the b on one side, half of the b on the other, which makes the dimensions of this b over 2 and b over 2. The dimensions of the red square are still x and x. And now it looks like we almost have a perfect square here. We need to add in some missing area, all right? And this missing area is going to be matching with the dimensions of whatever this is. In this case, we're going to keep everything symbolically, but if we multiply b over 2 times b over 2, we get b squared over 4, all right? Now, am I changing the problem when I add in this area? So far with the shapes, I haven't changed the problem. I just rearranged the terms. But now by adding this area, I do change the problem. And to balance that out, on the right-hand side, I'm gonna add in that little area that I added on the left. So we can add b squared. But what this essentially lets me do is, now that I have a perfect square, I could take the square root of both sides, and I'll be able to solve for x in both solutions. Completing the square algebraically. So I have x squared plus 6x plus 5. The first step I'm going to do, completing the square algebraically. So now I have x squared plus 6x plus 5. The first step I'm going to do is set it equal to 0. That means I need to subtract 5 from both sides to get it into this form. So x squared plus 6x is equal to negative 5. All right, over here on the left-hand side, my first step is to look at the b term and divide it by 2. So if I take 6 divided by 2, I have 3. And then I'm going to square 3. So that's going to give me 9. All right, this is the missing piece that I'm going to be adding on both sides in order to balance it out and in order for me to be able to take the square root. So if I go back in here and make some space for the 9, I'm going to add in the 9 right here. So plus 9, and then equals negative 5, and then plus 9. All right, so what's the big deal? I'm adding 9. I still can't solve for x, right? Well, if you remember, this right here is a special trinomial. It's a perfect square trinomial. So this is the same as having x plus 3 squared, right? Because I can take the square root of both of these, and the middle is the sum of twice the AB product. All right, and on the right hand side here I can add negative 5 and 9 to make up 4. All right, so I got to this form, x plus 3 squared is equal to 4. How does that help me get the solutions? Well, as you can see on the left hand side, I have x plus 3 squared, and I can take the square root of the left hand side. And I can also take the square root of the right hand side. And by taking the square root of this, the 2 and the root will cancel out, leaving just the inside, x plus 3. And finally, we were able to isolate the x. Now, the square root of 4 is equal to plus or minus 2. So we can set up 2 equations from this in order to get our 2 solutions. All right, if we subtract the 3 out from both sides, then one solution is equal to You can call it x1. The positive of 2, so 2 minus 3. And the other solution is the negative of 2. You can call this x2, negative 2 minus 3. All right, and this is how we get two solutions. So one solution is x1 equals negative 1. And the other solution is x2 equals negative 5. All right, let's do one more problem, but first I want to clarify. The difference between this and factoring is that this, it gives you your direct solutions, so you don't have to factor this out. We go straight into our x-intercepts. But some of the things that we talked about still help, like simplifying by the greatest common factor before we begin, because completing the square only works when works best if we have use a coefficient of a equals 1. So if we divide all these terms by 6, I can do that 0, 2, we end up with x squared plus 2x minus 8 equals 0. All right, so my first step is to move the c term to the right-hand side by adding 8 on both sides. It's going to cancel that out. And I have x squared plus 2x. And I'm going to leave some space for the piece I'm going to be adding is equal to 8. All right, so the piece I'm going to be adding is, I'll take the b and divide it by 2. In this case, 2 over 2 is equal to 1. And then I'll square it. So 1 squared is equal to 1. All right, so plus 1, plus 1. And now this is a perfect square trinomial, which I can rewrite as x plus 1 squared. And then on the right-hand side, I have 8 plus 1, which is 9. Now I can take the square root of both sides, and that leaves me with x plus 1 is equal to square root of 9 is positive and negative 3. And from here, the last step I can do is subtract 1 from both sides. All right, so this leads to one scenario of x equals the positive 3 minus 1, which is x sub 1 equals 2, one solution. And then the other scenario is if x is equal to negative 3 minus 1, which is x sub 2. Adding these two together gives me negative 4.